Good day everyone, it's your Jetty Bells, and for today's tutorial, we'll learn how to determine the radius, the center, and the interval of convergence of power series using the ratio test. But first, before we start, let me explain why power series convergence is important. Power series convergence is important because it determines whether a given power series represents a well-defined function for a certain value of x. And also,
Here are the
it
some
lies
key
in
terms.
its role
Radius of
in
convergence.
ensuring the
The radius of
validity and the
convergence of a power
applicability of
series,
mathematical
where is the
representations
summation of
and
a sub n,
computations.
the quantity of x minus c raised to n is the distance from the center c, the boundary of the interval where the series absolutely converge. It is given by the formula of r is equal to the limit of n approaches to the infinity and the absolute value of a sub n over a sub n plus 1. Center of convergence. The center of a power series with the summation of a sub n, the quantity of x minus c raised to n, is the value of x around which the series is expanded. This point is crucial because the series convergence behavior depends on the distance from C. The interval of convergence is the set of all x values for which the power series converge. It is typically written as the quantity of C minus R and the C plus R with open interval, but it may include one or both endpoints depending on whether the series converge there. Consider the series of 3 raised to n over n factorial. First, let's define a sub n, which is equal to 3 raised to n over n factorial. And an plus 1, which is equal to 3 raised to n plus 1 over the quantity of n plus 1 factorial. Now, let's take the limit as n goes to infinity of a sub n plus 1 times 1 over a sub n. So now the limit where n goes to infinity, isasubstitute natin siya sa value ng a raised to n plus 1. So, ang value natin dyan ay magiging 3 raised to n plus 1 over the quantity of n plus 1 factorial. And now, substitute naman natin yung value ng an, which is reciprocal siya ng 3 raised to n over n factorial. So, magiging n factorial over 3 raised to n. Now, we're going to simplify the absolute value of 3 raised to n plus 1 over the quantity of n plus 1 factorial times n factorial over 3 raised to n. Now, we're going to have the 3 raised to n times 3 over the quantity of n plus 1 n factorial. Then times, let's copy the n factorial over 3 raised to n. And now let's cancel the n factorial because Same lang siya dun sa kabila. And also the 3 raised to n. So what we have left over is the limit goes to infinity of absolute value of 3 over n plus 1. So, if n becomes large, 3 over n plus 1 is going to go to 0, and 0 is less than 1. So, therefore, we could say that the original series converges absolutely. So now let's use the ratio test again for our example number 2. Let's say we have 3 raised to n plus 2 times n squared over 4 raised to n. So now let's start the limit as n goes to infinity of the absolute value of a sub n plus 1 over 1 times 1 over a sub n. So now we're going to distribute the value of a n plus 1 and a sub n. So the value of our a sub n plus 1 is 3 raised to n plus 1 plus 2 times the quantity of n plus 1 raised to 2 over 4 raised to n plus 1. Then multiply the reciprocal of that fraction. So we're going to have a 4 raised to n over 3 raised to n plus 2 times n raised to 2. Now, let's simplify. Limit of n approaches to infinity. Notice that we have here a 3n plus 1 plus 2 and 3n plus 2. So, I'm going to separate the 1 from n plus 2. So, I'm going to rewrite it as 3n plus 2 times 3 raised to 1 because 3n plus 2 plus 1 is same as the other expression. Now, 4 raised to n times 4 raised to 1. In the quantity of n plus 1 raised to 2, we're just going to copy it. We have n raised to 2 there because we're going to take the n raised to 2 over there. We're going to move it. And everything else is, I'm just going to leave it the way it is. Or it's simply, we're just going to copy the other. Let's cancel the 4 raised to n and the 3 raised to n plus 2. Now, the constant of 3 over 4, let's take it outside of the absolute value expression. So, we move it in the front. Now, we're going to have 3 over 4 times the limit of n approaches to infinity with the absolute value of 3 of the quantity of n plus 1 raised to 2 over n squared. Now, let's expand the quantity of n plus 1 raised to 2. So, we're going to have that 3 over 4 times limit up n approaches to infinity. So let's expand it. So if you use FOIL, n plus 1 times n plus 1, we can get a n squared plus 2n plus 1 over n squared. And next, I'm going to multiply the top and the bottom by 1 over n squared. So now I'm going to have n squared times 1 over n squared. So 3 over 4 times the limit of n approaches to infinity. I'm going to have a 1 plus 2 times 1 over n plus 1 n squared over 1. But in this case, we don't need to write the over 1. So we're just going to have a 1 plus 2 times 1 over n plus 1 over n squared. So when n becomes really large, what's gonna happen? The 1 over n will become 0 and 1 over n squared will also approach 0. So we're just gonna have a 3 over 4 times 1. And so the limit is equal to 3 over 4, and 3 over 4 is less than 1. Given that, which means the original series is absolutely convergent. So now let's find the interval of convergence of the series n is equal to 1 goes to infinity, which is meron tayong x raised to n over the square root of n. So we'll use the ratio test. So everywhere you see an, replace it with n plus 1. So we're going to have the limit n goes to infinity, x raised to n plus 1 over the square root of n plus 1 times, we're going to multiply it with the reciprocal of x raised to n over square root n. So we're going to have the square root of n over the x raised to n. Now let's simplify it. Limit where n goes to infinity, the absolute value of x raised to n plus 1 times xn, then the square root of n plus 1 times multiply with the square root of n. Then we can have the absolute value of x times the square root of n over n plus 1. Then now we can factor out the x, but that comes out as the absolute value of x with the limit of n goes to infinity, the absolute value of square root of n over n plus 1. But under real, the radical, if things that about the limit as n goes to infinity of the square root of n over n plus 1, that simply is equal to 1. So all we left with is the absolute value of x. and we want to figure out if that is smaller than 1. Well, equivalently, this will give us the equation that x has to be between -1 and +1. So, what we have at this point is that if you take any numbers between -1 and +1 and plug it in x and plug it in our original series, then it's going to be convergence. But now we have to check the endpoint separately. So let's plug in the -1. So substitute our -1 to the value of n. So we can have the summation of n is equal to 1 goes to infinity and -1 raised to n over the square root of n. So now you can notice that it's now alternating series. Remember, for alternating series, you just have to simply show that the step without the negative in it, so you can think about that as being 1 over square root of n. And also we need to show that the limit is equal to 0, and that is correct. And also if 1 over square root of n decrease, which is absolutely it does. So now let's test the -1. Plug it in our original series. Summation of n is equal to 1 goes to infinity. Now 1 to any power is 1. So we're going to have 1 over n raised to 1/2. Now it's going to be a p series, which is p is equal to 1/2. But remember, for our p series, to converge this, but it's not less than by 1. So it's not that. But remember, for a p series, to converge, it must be greater than 1. But it's not also less than by 1, so it's not convergent. So in conclusion, we can say that our interval of convergence is between -1, because we justify that -1 here works up to but not included +1. So this is our interval of convergence. So now it's your turn. Try to solve these problems. If you find this helpful, please like and subscribe for more videos. See you next video.